Hello everyone, welcome back to this channel. My name is Omkar Tendolkar and today we are tackling a challenging problem from the International Youth Math Challenge IYMC 2024 qualification round. Especially we are proving that the n problem D from the qualification round, that is prove that n raised to 5 minus n is divisible by 5 for all positive integers. Okay, so without wasting more time we will directly solve our problem. So problem D is what? Prove that n raised to 5 minus n is divisible by 5 for all positive integer n. So this type of problem is a perfect example of how powerful mathematical technique like induction can be applied it to solve a problem step by step. So let's get into the detail. So before going to start actual proof, I will explain what is mathematical induction. Okay, so I will just shortly explain a mathematical induction. So mathematical induction. So actually mathematical induction is a method commonly used to prove a statement that are true for all natural numbers. It involves actually two essential steps. So first step will be the base case. The base case. In the base case, we start by proving the statement for the smallest possible value. It is typically 1, but not necessarily it always start with 1. Okay, so we actually prove the statement for the smallest possible value. Okay, and the second step is what? Inductive step. In inductive step. In the inductive step, we then assume the statement hold for a particular value, and such a statement is called as an induction hypothesis, and we try to show it is true for the next value. For example, if we assume that the statement is true for n is equal to k, then we always try to prove for n is equal to k plus 1, and if the statement is true for n is equal to k plus 1, then with the help of mathematical induction we can say that it is true for all positive integer n starting from the base case. Okay, so this was the short information about the mathematical induction, so we will not get deep into it. So without wasting more time, we will directly solve our actual problem, which is nothing but we want to prove n raised to 5 minus n is divisible by 5 for all positive integer. Okay, so I will write. So now let's apply this apply induction apply mathematical induction mathematical induction method to prove that to prove that n raised to 5 minus n is divisible by 5. Okay, so as I have mentioned earlier, so our first step will be the base case. So the step one it will be a base case base case. So first in the base case, as I have earlier mentioned, we will prove the statement for smallest possible value. Here we will try to prove for n is equal to 1. So let's verify the statement for n is equal to 1. For n is equal to 1. Okay, so n raised to 5 minus n. If I substitute n is equal to 1, it will become 1 raised to 5 minus 1, and we know that any power of 1 is 1, so 1 minus 1 is equal to 0, and clearly 0 is divisible by 5. 0 is divisible by 5. That is, we can express 0 as a multiple of any number, so 5 into 0, and hence the base case hold. The base case holds. Okay, so in the next step 2, so step 2 is about inductive hypothesis. Inductive hypothesis. That is, here we will try to assume that our statement is true for certain value. So assume that for some integer k, for some integer k greater than or equal to 1, the statement is true for all integer, for all integers from 1 to k, from 1 to k. Specifically assume that assume that for all n, for all n where n is greater than or equal to 1, less than or equal to k, n raised to 5 minus n is divisible by 5. Divisible by 5. It means it is true for all value from 1 to k, including 1 and k. Okay, so we for our convenience we assume that n raised to 5 minus n is divisible for n is equal to sorry, just a minute. So it is true for n is equal to k. So it is true for n is equal to k. So if it is true for n is equal to k, so we can write for n is equal to k, we can assume that k raised to 5 minus k is divisible by 5, and we know that if any number is divisible by 5, so it can be expressed as a multiple of that number. So k raised to 5 minus k is equal to 5d, okay, where d is any constant, d is any constant. Okay, so we will use this statement in next step, okay, in our inductive step. So our step 3. So step 3. So step 3 is nothing but inductive step. Inductive step. So in inductive step, we need to show that statement hold good. That means hold for n is equal to k plus 1. So we need to show that the statement hold for n is equal to k plus 1. We have assumed that it is true for all values from 1 to k, including 1 and k. Okay, so that is, we need to prove k plus 1 raised to 5 minus k plus 1 is divisible by 5. Is divisible by 5. Okay, so for that we need to expand k plus 1 raised to 5. Okay, so to expand k plus 1 raised to 5, we will use Pascal's triangle. Okay, so to expand k plus 1 raised to 5, we will use a Pascal triangle. For those who are unfamiliar with the concept of Pascal triangle, I will explain it in shortly. Okay, so Pascal triangle look like this: 1 1 1 1 2 1 1 3, 3, 1, 1, 4, 6, 4, 1 and 1, 5, 10, 10, 5, 1. Okay, so this value is for n is equal to 1, for n is equal to 2, for n is equal to 3, n is equal to 4, and n is equal to 5. Our actual problem is what? We need to expand k plus 1 raised to 5. So we will use the last rule, that is the coefficient of the expansion will be 1, 5, 10, 10, 5, 1. Okay, so I will write again. So the coefficient for coefficient for k plus 1 raised to 5 are are given by the fifth rule of Pascal's triangle, and they are as follows. So 1, 5, 10, 10, 5, 1. So the coefficient coefficient corresponds to the term corresponds to the term in the binomial expansion of k plus 1 raised to 5. They are like follows. So k plus 1 raised to 5 is equal to 1 into k raised to 5 plus 5 into k raised to 4 plus 10 into k raised to 3 plus 10 into k raised to 2 plus 5 into k plus 1. So it will be like k raised to 5 plus 5 k raised to 4 plus 10 k cube plus 10 k square plus 5k plus 1. Now we subtract k plus 1 from this expansion because we need to show that k plus 1 raised to pi minus k plus 1 is divisible by pi, and until now we have find the expansion of k plus 1 raised to pi. So now subtract k plus 1 from this expansion. So just a minute. So k plus 1 raised to 5 minus k plus 1. So the value of k plus 1 raised to 5, that is expansion of k plus 1 raised to 5, is as above. K raised to 5, 5k raised to 4 plus 10 k cube plus 10 k square. There is a just a minute. 10 k square plus 5k plus 1, okay, minus k plus 1. So now I will write k raised to 5 plus, I will remove the bracket. So now I will remove the bracket, is equal to k raised to 5 plus 5k raised to 4 plus 10k cube plus 10k square plus 5k plus 1 minus k minus 1, and we can easily cancel out this plus 1 and minus 1, and now I will rearrange the term as per our need. So k raised to 5 minus k plus 5k raised to 4 plus 10k cube plus 10k square plus 5k. Okay, I have just rearranged this term k raised to 5 and k like this. Okay, so by changing the order of the term, the answer will not get affected, and all the remaining term, that is 5k square plus 10k cube plus 10k square plus 5k, are written here in the second bracket. Why I am doing this? Because we can notice that 5k raised to 4 5k raised to 4 plus 10k cube plus 10k square plus 10k square plus 5k is divisible by 5 is divisible by 5 because because it is a sum of term, each of which is multiple of 5, each of which is multiple of 5. Okay, because you can see it is 5k raised to 4, 10k cube plus 10k square plus 5. Okay, so we can bring 5 outside the bracket. So if we are able to express any number as a multiple of 5, then that number is divisible by 5. Okay, so we will use that concept here, and therefore therefore rewrite the above expression. Let's rewrite the above expression. Rewrite the above expression as k plus 1 raised to 5 minus k plus 1 is equal to k raised to 5 minus k plus 5 in bracket k raised to 4 plus 2k cube plus 2k square plus k. Okay, and we already know that from the inductive hypothesis we have assumed that the statement hold good, that is hold for all the values of n from 1 to k including k. So for n is equal to k, we assume that k raised to 5 minus k is divisible by 5. So we assume that k raised to 5 minus k is equal to 5d, where d is any constant. So we will use this fact here. So I can write k raised to 5 minus k raised to 5 minus k as a simply 5d. Okay, is equal to 5d plus this term will be as it is. So 5k raised to 4 plus 2k cube plus 2k square plus k. Okay, so 5 is in the first term, pi is in the second term, so we can bring that 5 outside the whole bracket. So and we can write like this: pi in bracket d plus k raised to 4 plus 2k cube plus 2k square plus k. Okay, and since 5 in bracket d plus k raised to 4 plus 2k cube plus 2k square plus k is multiple of 5, is multiple of 5, it is also divisible by 5, it is also divisible by 5 by 5. Thus k plus 1 raised to 5 minus k plus 1 is divisible by 5, is divisible by 5, completing the inductive step. Completing the inductive step. So we have assumed that the statement hold good for n ranges from 1 to k, including and excluding, including 1 and k, and we have now proved that statement is true for n is equal to k plus 1. So we can conclude that. So we can conclude that by the principle of strong induction, by the principle of strong induction, of strong induction since the base case hold, since the base case hold, and the inductive step has been proven, and the inductive step has been proven n raised to 5 minus n is divisible by 5, is divisible by 5 for all positive integer n. So in this way, with the help of induction hypothesis, we have proved that the problem D from IYMC qualification round, that is n raised to 5 minus n, is divisible by 5 for all the positive integer, including step. First one was a base case, second one was inductive hypothesis, third one was inductive step, and lastly we have concluded that it is divisible by 5 for all positive integers. Okay, so we can use alternative approach to prove this question. Okay, so apart from the induction, this problem is can be also solved by using modular arithmetic, where you can test the value of modulo phi, and a factorization approach can be also considered by factoring n raised to 5 minus n. These are some alternative approaches which can be used for solving this problem. So now before going to stop, just take a look at the solution once again so that you can take a screenshot. Just a minute. Okay, so you can take a screenshot also. So problem D solution is like this. Okay, so okay, so in the next video, we will be exploring another challenging problem from the IYMC and dive deeper into advanced problem solving technique that you can apply in maths competition. So if you enjoy this video, make sure to like, share and subscribe to this channel for more content, and also hit the notification bell so you never miss an update. Thank you for watching, and I will see you in the next video. Bye.